Hi, my name is Jacob, and today I'm going to be discussing with you my project entitled Inter-car-munication. So, I love cars, and it all started when I got a 2000 Nissan Altima with almost 300,000 miles on it. Needless to say, this car needed some love. It needed my help almost every single week just to stay alive, and so I learned a lot about cars through that. And I also interned at a place called NIFCO America the last 2 summers as a design engineer. First year I did a lot with cost analysis with injection molding, and the second year I did a lot with R&D, which actually you'll see my project from that internship later in this presentation. So from these experiences, I learned that cars are extremely complicated and they get more and more complicated every single year. So the focus for this project is communication between cars and between drivers and all sorts of things. So currently, there are only 2 ways that we communicate with other drivers. We have our horn, which is extremely one-dimensional, only communicates anger and annoyance. And we have lights, which only communicates either a turn with your turn signal, or you can flash someone with your brights, but nobody knows what it ever means. Usually there might be a deer or it might be police, but it really could mean anything. So more things happen on the road though than you turning and you getting angry. So that's a problem, and how do we communicate these things? Now on the other side, we do have anger on the road, such as road rage. And I know road rage is the extreme, but everyone experiences some sort of anger while driving. And most people think that they're the best driver on the road, and I am definitely guilty of this at times. And I wonder though, if we were able to see the full picture of like, why did that person cut me off? Did they think they had the space? Would I have slowed down if they were able to communicate with me that they needed to get out? All of this stuff we don't know. If we saw the full picture, would we be better drivers and would they be better drivers? So let's do some background research. So vehicle safety is a very interesting topic. Every car company has some sort of focus on car safety. So whether it is for a good image or for genuine care of the public, the focus is still there. I have this quote from Greg Winfrey in an interview with George Pudick. It says that the first 50 years of transportation safety, they were focused on surviving crashes. We see the future as technology that avoids crashes overall. This is a very, very key shift in the way that we look at transportation safety. So it started with survival, and now it's focused on crash avoidance altogether. So how are most people going about doing this right now? Well, the biggest one is car-to-car communications. So this is very, very cool stuff. So the focus right now is on artificial intelligence. So this uses an ad hoc, which an ad hoc network is just a temporary network communicating directly between devices. So this uses an ad hoc network to communicate speed, direction, position, and all sorts of other information to use to predict things. So this information could help to avoid potential crashes using this information, and could result in a lot of different really neat things, such as virtual traffic lights and virtual traffic signs, and we may never see road signs again when this is completely implemented. So sounds really neat, but there are definitely some disadvantages to car-to-car. And while I will be talking about these disadvantages, I want to say that car-to-car is really neat, and someday, years in the future, I believe it will be really, really valuable to the road safety. But right now, AI is extremely difficult to program, understand, and especially implement into cars. And another disadvantage is that every single car on the road has to use this for them to work properly. Say a car without this feature comes up to a virtual traffic light, what are they going to do? They don't know what to do at that stoplight, and the other cars aren't even going to see that that car exists. So they won't be taking that car into consideration. So there's lots of issues there. Also, AI struggles in reading human nuance. With over the first 1 million miles that Google had on their self-driving system, they were blamed for only 1 accident. And this accident was due to a lack of social nuance. Essentially, these cars were trying to merge, and they both assumed different outcomes to that merge. Thus, they collided. So this previous thing shows that passive communication, where drivers aren't actually inputting any data, it's just the car doing it automatically, is great, but we need more than that. This last example shows that there's a lack of nuance. We need active communication as well. So There is an area that is focusing on active communication. On the complete other side of the spectrum, we have social driving. So it gets very interesting here. So overall goals of social driving include making driving more fun, motivating drivers to drive more safely, and enhancing driver empathy even. So what does this look like? Driving as a social game. So we have some potential social features and safety enhancing features. So the social ones include drivers earning points for communicating and for having safe driving, and this could result in driver leaderboards, weekly leaderboards, and things like that. You can share photos, you can share music with other drivers, and you can share and rate locations or even share and rate roadways. For instance, there's this really awful road in Johnstown that I would give a really nice 1 star to. So we also have safety enhancing features. One of these things is the ability to potentially submit city maintenance requests. Maybe for that road in Johnstown, I could submit a maintenance request to some of those potholes. We could even inform nearby drivers of emergencies, like maybe you're driving an injured person to the hospital, or maybe you're driving a pregnant mother who's about to give birth to the hospital. You need right of way. Now, there's other instances where you might just be performing an action. Maybe you're attempting to parallel park, or you want other drivers to know that you're pulling out of a parking space in aisle A of Kroger. All of these different things could be told to other drivers to potentially avoid crashes. If you didn't think about it before, there's a very big downside to this, and that is the potential for distraction. Social media of any kind in cars can become very dangerous very quickly. So I tried to go somewhere in between these two methods in my methodology. So I'm proposing 2 methods as first steps. And I want these methods to be safe and simple to use. I want them to be able to be added to any new or any used car, and they will not require every car on the road to use them. So method 1 is the parallel parking indicator. And it does exactly what you would expect it to do. It notifies people behind you that you're about to parallel park, so hopefully they can give you the proper amount of space behind you so that you can do that action. So the main features of this include that it's attached to your license plate, it activates at the push of a button, and it resembles a top-down view of the parallel parking process. This project was the one that I developed with NIFCO at my 2nd year of my internship there. So the signal design, the shape is the top-down view of the parallel parking process, as I said earlier. The cars were shaped very specifically so that they could be easily injection molded, and the colors were chosen very intentionally as well. The blue active car was chosen because blue is commonly associated with public parking, and white is associated with parked cars, and it's also just a neutral color, so that's why we chose white for the neutral cars. So signal pattern is almost like you might expect it to be. So it starts by illuminating all 3 cars and 1 portion of the arrow. Then it fills in the next portion of the arrow until the arrow is filled in completely. So it's like this swooshing effect as the arrow fills in, and then it turns off the signal altogether. So this is a 5-step pattern. It repeats continuously once the button is pressed, and it stops when the car is placed in park or when the button is pressed again. And the rate that it repeats is the same rate that your turn signal repeats. So the materials it took to build this are listed here. So the first thing is the Arduino. An Arduino, it served as the heart of this project, really. Essentially, technically it's a microcontroller, but essentially all it does is it takes a program that you write, and it has input and output pins, and you essentially tell those pins what to do. So it's a programmable board that does things to electronics. So for construction, we needed a foam board and an acrylic panel to build the actual license plate itself, or the license plate bracket, excuse me. And we also needed a switch as a power for on and off. And we needed 10 high output LEDs for illumination. These were basically the lights of the system. And I also needed some MOSFETs and resistors. MOSFETs are a certain kind of transistor. It essentially allows you to control the voltage that you're outputting. Both of these devices were for better control of voltage. So the final prototype, I don't have it here with me in person, but this is what it looks like. It is on the back of this car in the showroom at NIFCO. So for feasibility of this design, it has some really good advantages. It's really easy to implement, it's a simple design, and power is already run to the license plate for license plate lights, so only a data wire is needed to be added. It's also extremely easy to understand. Hopefully the first time someone sees this, they can know what it's trying to tell them. There are also some disadvantages though, the biggest one being it's an asymmetric design, and this could contradict some design languages of major manufacturers. This was done for easier injection molding and quicker implementation, but the design could be changed in the future as well. So for method 2, we have a message board. This message board is also what it sounds like. It communicates messages to drivers behind you. So the main features include that it's attached to your rear windshield, and it displays different messages based on what button you press in your dashboard. So there it is right there, showing the word stop. So for materials of this, it required very similar materials to the last thing. So we needed an Arduino once again, and we also needed an LED matrix. So this matrix is essentially the screen of the operation that displays what we're trying to tell the drivers. And I also needed 5 buttons to control what message is being shown. So here it is in action. The first button says stop. The second button activates watch ahead. Third button activates police, and fourth button has park flashing until you press the 5th button to turn it off. So for feasibility of this design, it has very similar advantages to the previous design, as it is very easy to implement. It has a simple design. Power is usually run to this area as well, usually a third brake light or something like that, so only a data wire is needed to be added once again. And it's also very easy to understand. If someone can read, they can understand this message. So it does have some disadvantages though. This could potentially be tampered with the proper knowledge. Somebody might be able to take this sign and reprogram it. But there are ways to code past that, so hopefully in the future that won't be possible. Also, the messages must be extremely brief due to a limited board width and potential of distraction if the message takes too long to read. So in summary, we talked about how communication for drivers is extremely limited right now, and this causes the roads to be a little more unsafe. And I propose 2 small steps that can be taken to alleviate this. So my hopes for the future with this project is that drivers could potentially be more engaged, have better information to consider while driving, and be able to make better decisions with that information. I hope that driving will be less frustrating and even a little more fun. And I hope that we can shift the way that we view driving, but more importantly, shift the way we view other drivers. That's all I have. Thank you so much for watching. All of my references are after the slide and in the description. If you have any questions, please feel free to leave them. I will answer them. Thank you.